Hello everybody, welcome into another lesson. So today we are going to talk about solving equations that have grouping symbols like parentheses. So here we are given the equation 2 times the quantity of d plus 6, that is equal to 3d minus 1. Well, basically all you're going to do is the distributive property wherever you see those parentheses. So if we take 2 times d, you'll get 2d plus that 2 times 6. Then you do plus 2 times 6, well, that'd be 12. You'll set that equal to 3d minus 1. So we've expanded this out now from the distributive property. We've set it equal to the right-hand side. Now we got a type of equation like we did yesterday, where we have the variable on both sides. Well, we're going to do just like we did yesterday. We're going to try to get the variable out of the right-hand side and keep it only on the left-hand side. So the right-hand side, we have a positive 3d. We need to subtract 3d to get rid of the variable. So you'll have 3d minus 3d on the right-hand side. Then you have that minus 1 that's hanging out. But since you did it to the right side, you got to do it to the left. You'll end up having 2d minus 3d, then you'll just have that positive 12 that hangs out. Okay, well, let's go on the left. 2d minus 3d, that's negative d. You'll have negative d plus 12 is equal to the right hand side, 3d minus 3d. Well, that's just 0, but you have that minus 1, so now you're left with negative d plus 12 equals negative 1. Well, we got the variable on the left-hand side. We've achieved one goal. We want to get the variable by itself now. We want to get that negative d by itself. We have plus 12. We need to do minus 12. So you'll have negative d plus 12 minus 12. You'll set that equal to negative 1 minus 12, because what you do to one side, you got to do to the other. Well, on the left side, 12 minus 12 is 0. You now have negative d by itself. You'll set that equal to negative 1 minus 12. That's negative 13. So we got negative d by itself. We want to solve for just plain old d. Well, you got to divide both sides by negative 1 is what you'll have to do to get d by itself. On the left side, the negative 1's cancel out. You're left with d all by itself. Then you have negative 13 divided by negative 1. That'd just be positive 13. So the answer to this is d is going to be 13. And if you want to check your work, you can always put 13 in for wherever you see d, and you'll end up getting a true statement. The left side will equal the right. So I do got a few more examples here. So really, once you do the distributive property, this just turns into what we did yesterday. Equations with variables on both sides. It's really not too bad to do these. Alright, this time, let's see. We have 6n minus 18. We're going to set that equal to 4 times the quantity of n plus 2. Okay, so we have 6n minus 18. We're setting that equal to the quantity of 4 times n plus 2. Well, first thing I would do, you have a distributive property on your right-hand side. I would take care of that. Let's stick with writing the 6n minus 18 on the left-hand side. I'd like to use a different color for work on the problem. Alright, so we'll have 6n minus 18 on the left-hand side. Now let's do, on the right-hand side, you have 4 times the quantity of n plus 2. Let's do the distributive property. 4 times n, well, that's 4n. Then you have plus 4 times 2, well, that's 8. So now you've done your distributive property and you've got it down to where you just have an equation with variables on both sides. Of course, in true fashion, like I like to do, I like to get the variable off the right-hand side and make it only on the left. So we have a positive 4n, we need to do minus 4n. So on the right side, you'll do 4n minus 4n. Then you have that plus 8 that's hanging out there. But since you did it to the right side, you got to do it to the left. So you'll have 6n minus 4n. Then you just have that minus 18 hanging out. Alright, start with the left. 6n minus 4n, that's 2n. So you'll have 2n minus 18. Set that equal to your right side, 4n minus n. Well, that's 0, you'll just have 8. So now you're left with a variable equation of 2n minus 18 equals 8. You got the variable on the left side where you want it, but we want to get the 2n by itself. Well, we have a minus 18. That means we need to add 18 to get the variable by itself. So you have 2n minus 18 plus 18. That's going to be equal to 8 plus 18, because what you do to one side, you got to do to the other. Okay? So now on the left side, you have negative 18 plus 18. That's 0. You're left with 2n by itself is equal to 8 plus 18. That's 26. Now you have 2n equals 26. Well, we just want to solve for n. You got to divide both sides by 2. Left side, the 2's cancel out. You're left with n. That's going to be equal to 26 divided by 2. Well, that's 13. So the solution to this is n equals 13. That's what you would get. All right. What do we have here for the next problem? Oh, good one. So we have 3 times the quantity of a minus 3. We're going to set that equal to 2 times the quantity of a plus 4. So we have a double distributive here. We have 3 times a minus 3 equal to 2 times a plus 4. Well, since you have grouping symbols, I would always do your distributive property first. We'll take that on both sides. So 3 times a, well, that's just 3a, minus 3 times 3, that's 9. We'll set that equal to the right-hand side, 2 times a, that's 2a, plus 2 times 4, that's 8. So we've done our distributive property. We've come up with 3a minus 9 equals 2a plus 8. Now we just have an equation with the variables on both sides. Of course, we want to get rid of that 2a off the right-hand side and make the variable on the left-hand side. So what you got to do to get rid of that 2a on the right, subtract 2a. You'll have 2a minus 2a. Then you just have that plus 8 that's hanging out there. So since you did it to the right side, you got to do it to the left. So you'll have 3a minus 2a. Then you just have that minus 9 hanging out. So we'll start with the left side. 3a minus 2a, that's simply a. Then you have a minus 9 is equal to, what, 2a minus 2a, that's 0. Then you just have that positive 8. So now you're left with a minus 9 equals 8. This doesn't look too bad to solve at all. You have a minus 9, you want to get a by itself. You have a minus 9, you need to do a plus 9 to make that happen. So you'll have a minus 9 plus 9 is equal to 8 plus 9. Since you did it to one side, you got to do it to the other. On the left side, negative 9 plus 9, that'll go to 0. You'll just have a equal to 8 plus 9, which is 17. So the answer to this is a equals 17. I think we could do at least one more example. I don't intend to make this a super long lesson because It's basically what we just did yesterday, only we have one more step where we just got grouping symbols, so it's really not too hard. And we might do 2 more problems, actually. Alright, so let's see. We have 3 times the quantity of S plus 22. We're going to set that equal to 4 times S plus 12. Alright, so we got 3 times the quantity of S plus 22 equal to 4 times the quantity of S plus 12. Well, we'll go ahead and do our distributive property on each side first. So on the left side, you have 3 times S. That would just be 3S. Plus 3 times 22, that would be 66. So the left side, you got 3S plus 66. You'll set that equal to, let's do the distributive property of the right-hand side. 4 times S, well, that's just 4S. Plus 4 times 12, that's 48. Okay. Now we have an equation with the variable on both sides. Of course, in true fashion, what we need to do is get the variable off the right-hand side, make it only on the left. You have a positive 4S on the right side. That means you need to subtract 4S. So you have 4S minus 4S plus that 48 that's hanging out there. But you've done it to the right side. You got to go ahead and do it to the left. So you'll have 3S minus 4S plus that 66 that's hanging out. Well, on the left side, let's start 3S minus 4S. That's negative S. You'll have negative S plus that 66. You're going to set that equal to the right side. 4S minus 4S is 0. You just have 48. Alright. So we have negative S plus 66 equal to 48. Well, we want to get that negative S by itself. So let's go ahead and do that by, we have that positive 66. We need to subtract 66. So you'll have negative S plus 66 minus 66 equals 48 minus 66. Alright. So now on the left side, 66 minus 66, that's 0. You're just left with negative S all by itself. Equal to the right side, that 48 minus 66, well, that's negative 18. So you have negative S equal to negative 18. Well, we got negative S. We want to solve for just plain old S. So you got to divide both sides by negative 1. Left side, negative 1's cancel out. You just simply have S is equal to negative 18 divided by negative 1. That's positive 18. And if you put this in, I guarantee you get a true statement. Yep, you sure would. So S equals 18. We'll do one more example here. One more, and then I'll call it a day. Alright, we have 8y minus 5 is equal to 5 times y minus 1 plus 3y. So this one looks a little bit more like a doozy, because on the right side you have a distributive property and you have another coefficient with a variable. That's okay. We want to definitely do our distributive property. So let's start with the left side. We'll keep that 8y minus 5. We'll set that equal to 5 times y, which is 5y, minus 5 times 1. Well, that's just going to be 5. Then you have plus 3y. Okay, so now what you'll do just keep your left side the 8y minus 5. On the right side, let's add the like terms. The 5y and the 3y, you'll get 8y minus 5. We're about to discover something very interesting here. So, you have, of course, you have a variable on the right-hand side. You want to get rid of that variable. So we have positive 8y. We need to subtract 8y. So then 8y minus 8y. Then you have that minus 5 hanging out. What you done to one side, you got to do to the other. You'll have 8y minus 8y. Then you have that minus 5 hanging out. Well, left side, 8y minus 8y is 0. You just got negative 5 is equal to, on the right side, 8y minus 8y, that's 0. You just have negative 5. Well, all you're left with is a true statement. Negative 5 certainly equals negative 5. What do you do in those cases? The answer to that, whenever you come up with just a true statement, there are infinite solutions. There are infinite solutions to this, which means you could put in any value for y. You can put in any value you want for y, and the right side will always equal the left whenever you have infinite solutions. So if you come up with a true statement, you got infinite solutions. That's what you got. You know, I suppose we'll do one last one like it, because I want to reiterate the point. But if you just got a true statement, there are infinite solutions. Actually, I'll do two more examples, because I want to do... There's a method to my madness here, and a madness to my method. But alright, so we got 10z plus 4 is equal to 2 times 5z, 2 times the quantity of 5z plus 8 minus 12. Okay, so we have here 10z plus 4 is equal to 2 times the quantity of 5z plus 8, that whole thing minus 12. So, of course, we're going to start like we would any other problem. Keep your left side the same for now. You'll have 10z plus 4. We'll set that equal to, we need to deal with a distributive property here. So 2 times 5z, that's 10z. Alright, and then we have plus 2 times 8, that's 16. Then you just have that minus 12 hanging out there. So you have on the left side 10z plus 4. You'll set that equal to, let's simplify the right, you have 10z. Then you have 16 minus 12, that's just plus 4. You see what we're set up for? We're set up for just getting another true statement. The right-hand side, we want to get rid of that variable, get rid of that 10z, so we'll do 10z minus 10z, and then we just have that plus 4 hanging out. Alright? And what we've done to the right side, we got to do to the left. You'll have 10z plus, no, I'm sorry, 10z minus 10z, then you just have plus that 4 hanging out. While left side, 10z minus 10z is 0, you just get 4. You'll set that equal to the right side, 10z minus 10z, that's 0, you just have positive 4. You have another true statement. You just end up with a true statement. 4 equals 4, meaning you have infinite solutions. You got infinite solutions to this. So that means you can stick in any value of z that you like, and you'll get the left side equaling the right side every time, whenever you have infinite solutions. Alright, I'm going to change this equation slightly for the last example. Let's make this minus 13. Alright, so now we have 10z plus 4 equal to 2 times a quantity of 5z plus 8 minus 13. Well, we'll do what we did already. We'll keep the left side the same. We'll have 10z plus 4. We'll set that equal to, let's do the distributive property, 2 times 5z, that's 10z, plus 2 times 8, well that's 16. Then you have minus 13. Alright, left side stays the same for now. You'll have 10z plus 4. That's going to be equal to 10z. Then we have 16 minus 13, that's 3. So you have 10 plus 4 equal, 10z plus 4 equal to 10z plus 3. Well, we want to get the variable off the right-hand side, so on the right-hand side you'll do 10z minus 10z. Then you just have that plus 3 hanging out. Which means you done it to the right, you got to do it to the left. You'll have 10z minus 10z, then you'll just have that plus 4 hanging out. Left side, 10z minus 10z, that's 0. You just get 4 on the left. You'll set that equal to the right side. 10z minus 10z is 0. You just got 3. Well, you got 4 equals 3. We know that's a false statement. 4 certainly does not equal 3. If you just come up with a false statement, for your answer, that means you got no solution. There's no solution to this. So the ideal situation is you got a variable equaling a number. Then you have, well, of course, the variable equals the number. But if you get a true statement, if 4 would have equaled 4, you would have had infinite solutions. There would be no value of z that you couldn't put in where you wouldn't have a true statement. But when you got a false statement, such as, one side does not equal the other, we know 4 does not equal 3, there's no solution. There's no value of z that you could put in that would make these equations equal. That would make the left side equal the right. So that's just something to bear in mind. So that's it for this lesson. The very next lesson we're going to start talking about equalities, inequalities, which lead into us solving inequalities altogether. So I hope everybody has a good night. Take care.